Hello people, here we are again, back to the materials, but this time in the advanced course. So we're gonna touch some advanced topics, of course, and gonna give you even more creative control on the objects in your scene and the image overall, of course. So what are the goals of this part of the course? Well, first, getting familiar with the shader editor in Blender. And second, creating realistic images with texture mapping. So mapping images onto your 3D objects. Learn about some advanced material settings. And of course, this is still in the scene part of the pipeline. So why do we do this? Well, of course, same as in the basic course, you want to have creative control over the appearance of your 3D objects. And in this case, we're going to give you even more creative control over these objects. I would say it gives you even an infinite amount of control over the appearance of your 3D objects. The shader editor is very, very powerful when it comes to that. So, for example, you can go from this with the basic materials, just a red hue on the blood cells and a little pinkish hue on the blood vessel, to this, where you have a more microscopic look, for example, with the bumps and the heavy Fresnel effect. Fresnel is the way the light rays bounce off the edges of an object. So when the angle of incidence is very steep. When it comes to this white shading effect, which you always see in these microscopic images. And I also added some noise textures on the normal map, so you get these little indentations where the light reflects differently. And then I used a stack of noise images and adaptive subdivision to displace the geometry in the direction of the vertex normals. And then you get this bumpy looking surface, which you usually see in these microscopic images of blood vessels, for example. And the same goes for the blood cells. Of course, you can also see a noise map is placed on these blood cells, where you get this little bumpy looking texture, which you also have on these blood cells in the microscopic images. Also this heavy Fresnel effect, where you see these white fringes around the object itself. And this way you can create like a very realistic blood cell image just with the shader editor. And you can go from this very flat image to this, which is basically kind of the same which you saw before with the microscopic image from the blood vessel. But in this case, I also combined a translucent shader with the normal Principled BSDF shader to make it more transparent. And of course, the same Fresnel effect is added, and this makes every single bacillus pop out. And you can even go from this, a normal cube with a flat color, to this. Of course, this is a very extreme example, and there's a lot of adaptive subdivision going on, a lot of displacement going on, with a stack of textures, with a Voronoi texture which creates these bumps, with a Musgrave texture which does the coarse displacement, and with a noise texture to create these tiny little bumps. And there is subsurface scattering going on, and actually there is also emission going on within the subsurface scattering, these red little blobs here. So as you can see, you can create your own geometry with the shader editor itself. And this is of course an extreme example of what you can do with it, but in a sense of skill, this is still a minor thing you can do with it. There are some people that do crazy stuff with the shader editor, and I will show you an example later. So now that we know why with some examples, we can gonna go to the how. So how do we get this creative control over your 3D objects in the scene? With the shader editor, which I already spoiled before. But as you can see, this is a very complex node network. Of course, you don't have to do this for the images I showed you before, because this is actually a network to go from a normal sphere to this microbe, animated. As you can see, again, it generates its own shape. But yeah, this is advanced shader editing. This is created by Simon Thomas, who does this November challenges in November, where you create your own objects or textures with the shader editor, and every day there's a different object that needs to be created. And on day 9 it was the microbe. And Simon Thomas even landed a job at the Blender Foundation because of this. So yeah, this is not something that you have to do, but it is possible with the shader editor. So now back to the normal side of things. This is how I did it with the bacillus image. It's relatively simple. This is a Principled BSDF, which we already seen before in the basic course. And I used a mixed shader to mix a transparent BSDF with the Principled BSDF, and then added another mixed shader to get a little bit of emission going on the edges, to get this white popping edges around the objects with the Fresnel node, and then put that mixed shader into the surface of the material output. So the surface of the object will then look like what you defined before that. So what is this shader editor? The shader editor is a node-based visual programming tool for materials in Blender. And when you add a material to an object in Blender, in the background it already creates this node network for you, which will have one Principled BSDF with its output connected to the surface input of the material output node. And this already creates a very pleasantly looking image, and you can already adjust a lot of things on this Principled BSDF. But yeah, what we want is even more control, of course. So what can we find in this shader editor? We can find a shader graph which contains different node types connected by edges. And basically it's a pipeline going from inputs, for example, texture coordinates, object information such as the location, the color of the object index, the material index, or even a random value, or just a value that you define yourself, to different types of nodes in between connected by these edges, and then towards the shader, the BSDF, and then towards the surface of the material output, and then it creates an image based on all of what has been defined before that. And with this shader graph and these different node types, what you basically do is manipulating the values that come out of the nodes, the output, to the inputs of the other nodes. And the different values are, for example, the gray ones are just values, for example, floats. And the blue ones are vectors, and the yellow ones are colors. And the difference between that is that the vector is X, Y, Z, and the color is RGB. But yeah, they are interchangeable sometimes. And the green ones are called closures, and you will usually find them at the end, which is basically a function which you pass on to the material output, which defines how the light bounces off the objects. The different types, I already explained you the input node type, which is just a set of nodes with different values you can get from the scene itself. And the second type is the vector node type, which performs operations on vectors. For example, in this case, it is the mapping node, which transforms the input vector to a different location, orientation, and scale. So if you want to change, for example, your texture mapping, you want to scale up the size of your texture on how it looks on your object, you can use the scale for that. Or you want to rotate your texture, or you want to change the position of your texture, you can do that as well with this node. And then you have the texture node type, which is a set of nodes with which you can either load image files as textures or you can use one of the procedural generated textures. For example, in this case, the noise texture is one of the procedural generated textures. And then we have to convert the nodes, and these convert values and factors into other values and factors, such as this color ramp, which is a widely used converter node. With this, you can change a value with the range from 0 to 1 to a color based on a color map. This is very useful when it comes to visualization as well. Besides that, you also have a math node, and that math node you can do everything such as add, subtract, multiply, divide, floor, ceiling, all those kind of mathematical operations. And then we have the color nodes, and as you might have guessed, that is used to manipulate colors, to manipulate the RGB values of those colors. And then we have the layout. No, well, it's actually not node types, this layout, but it's just used to organize your graph a little bit better. For example, around every set of nodes, I placed a comment box, what they call a frame. And in this frame, you can place a comment in the top, and then you can organize your graph with these frames. And also you have these reroute nodes. These are very useful when a lot of lines go out of the same node and they have to go all across the graph. And then you can place one edge out of that node all across the graph and place a reroute node, and then eventually connect all these inputs to this reroute node. And then we have the shader node types, such as this Principled BSDF, which generates these BSDF functions to input into the output of the material. And other nodes of this type, for example, are the diffuse node, the glass node, the glossy node, and the transparent node. And finally, but not least, is the material output, which is an output node where you can plug in your surface or your volume, if you have a volume shader, or the displacement of the material. And that is basically what the shader editor is, and I will go into depth into it with the hands-on after I told you something about texture mapping and displacement. So the next part is texture mapping, which is mapping images on a 3D object. And the usual way that this is done is with this simple pipeline. First, you need a 3D mesh to map your image on, and then you UV unwrap this mesh into a 2D space called the UV space. And how this unwrapping is done, I will tell you in the next slide. And second, you need a 2D texture, and in this case, this is the surface of the moon. And then the unwrapped mesh and 2D texture are mapped on top of each other, and then you can derive a color value for each UV coordinate position of a vertex in the UV space, which is mapped onto the 3D object. And then the final result is a 3D mesh with the texture mapped on top of it based on the UV unwrapping. Now a little bit more about UV unwrapping. There are many ways to map a 3D mesh into the UV space. Some commonly known in Blender are the unwrap, which is a very basic unwrapping by defining the edges on a surface as seams. So basically what Blender does is then cut it like with a scissor and fold it out into the UV space. For example, the sphere you saw before, just on one side you cut a seam and then it will unwrap it like that. And the second type is the Smart UV project, which is an algorithm that automatically determines the seams by a defined angle threshold. And this is very useful when you have a very complex geometry and you don't know exactly how you want to unwrap your object into the UV space. So for example, if you have a very complex visualization, this could be a way to unwrap your mesh, but it can also make the UV mapped geometry very complex. So you get a lot of single islands in the UV mapping, which can look funny when you eventually map a texture on top of it. And another one is the project from view, which is a very easy one. So basically when you look at the side of an object and then select project from view, and then the 3D object is literally mapped from the 3D point of view onto the UV space. This is very useful when you need to map an image on an object which you only see from one side. Then you can basically just project from view, and then you have a nice image onto that object. But if you would look at it from the side, then it would look wrong and all the textures will be stretched out on the side. But yeah, I will go into this as well in the hands-on for a better explanation about these texture mapping types. When you're mapping textures on a 3D object, you also have different types of textures you can map on your 3D object. You can map, for example, a diffuse or color texture onto your object, which is just basically color values which you want to have on your 3D object. And then you have the normal map texture, which is a vector image, and each pixel has a vector showing in which direction the light should bounce off the 3D object, which you can put into your normal input of your shader. And then you have the roughness texture, which basically determines how rough a object is at a certain place of that texture coordinate. So for example, in this roughly painted wooden surface texture set, the lines in between the wooden planks are a little bit more rough than outside of it, as you can see in the image as well. And where the paint is still a little bit shiny, the roughness is a little bit lower. And that way you can have a variable roughness on your 3D object with this texture. And then you also have the displacement texture, which determines how far a vertex needs to be displaced along a normal. So basically with the wooden plank, the ridges are lower and the planks are higher. So on the plank surface, the vertex needs to be displaced a little bit more than they would be in the ridges. And in that way you get a nice displacement map and you can get these ridges visible on your 3D object. And what I just showed you right now is called a PBR workflow, a physically based rendering workflow. They have color, normal map, roughness, and displacement. You also have other textures like the metalness of an object. This is a metal map, and the ambient occlusion map, and so forth and so forth. But the most used textures I showed you right now is the color, normal, roughness, and displacement maps. But now you might wonder, where do I get these textures from? I mean, do I have to make my own pictures? Yes, you can. You have a whole texture making pipeline which you can do with Photoshop, which actually some companies do, and then they sell those textures. So some great sources are the texturehaven.com, which is a very good one, which has very nice textures, but they don't have that many. And then you have CCO Textures, which is also a texture library, but they are a little bit less quality. And then you have the paid services, for example Polygon, which is a very large set of textures which you can download. If you pay a monthly subscription, then you get credits and then you can download textures with these credits. There are some free examples on this website as well which you can use, but the quality of these textures are amazing. I have an account myself. I'm not having a subscription, but I just use the free ones, which is good enough for me, for my purposes. And if they don't have the texture that I want, I go to Texture Haven and use the textures from there. And then you have Megascans, which is also a very large library, not only for textures, but also for 3D objects, which is free in a sense. It's free when it's connected to your Epic account and when you use it to make assets for your Unreal Engine games, for example. And then textures.com has also very high quality textures as well. These sources can also be found in the references in the course material. And Now to go into a little bit more depth into this displacement map. This displacement map will only work when you have a very fine geometry, if it actually has a lot of vertices to displace. For example, if you have a plane, you only have 4 vertices on the edges, and only these 4 vertices will be displaced by this texture. So it's quite useless to use this displacement texture on a sparse 3D object. But there is a solution for that, and that's called adaptive subdivision, which is an experimental feature of Blender. And what you do then is use the displacement mapping on a adaptive subdivision. And what adaptive subdivision does is it subdivides each face per n amount of pixels before applying the displacement map. So for example, if you subdivide the faces based on 1 amount of pixel, it will, for every pixel, it will subdivide the mesh. So for every pixel, it has a vertex to displace, which makes the object look highly detailed. And an example has been shown here. Without the adaptive subdivision, you can see it has a very coarse displacement. But with adaptive subdivision, you can perfectly see the displacement map on the object itself. And in this case, I think it was a Musgrave texture. But keep in mind, this is only an experimental feature of cycles. So it cannot be used in Eevee, so only in cycles. And you have to keep in mind, if you do a subdivision per 1 amount of pixels, it generates a lot of geometry that has to be stored on your GPU. So your GPU needs to be able to handle this amount of geometry. So I usually start with a subdivision per 4 pixels and then go down from that to see if my graphics card can handle it. So now that we went through all the theoretical stuff within these slides, I will go into Blender and show you all these things more interactively, and you can also follow along or just look at the video and eventually use everything you learned in these slides and in the hands-on with your assignments. Okay, so now that we are in Blender, we can put everything we learned just now into practice with this hands-on. So first, we're going to open up the Advanced Materials blend file, which can be found in the walkthrough directory in the Advanced Material directory. You can also see there is a Advanced Materials final results blend file. And this will give you the final results on how everything should look like when you applied everything. So when we open it up, we see just standard Suzanne. Nothing special, but the layout is a bit different. I already added a shader editor to the layout. As you can see here, this is the editor type shader editor if you hover over it. It can also be found here in this list. And if we look at Suzanne and we put the render mode, the shading mode into rendered, you see it has just a normal HDRI lighting, nothing special, just a white Suzanne. But we are going to change that now. So now we're going to go into a simple example workflow on editing materials in the shader editor. Of course, there is a very large extent of node types you can use, but I will not cover them all because I don't have enough time for that within this course. But it should get you started and get familiar with the basics of this shader editor to do your assignments, and maybe spark your interest to research into any other node types that are available, which you can use for your visualization. So first off, we need to create a node network. We're going to do this by simply pressing the new button in the top bar of the shader editor, or we can go to the properties panel to the materials tab and press the new button. This is the same button. As you can see, if I press this one, it will also generate the familiar from the basics course material settings on the side. And as you can see, it generates a simple network already, a principled BSDF, and a material output. Without a BSDF function, Suzanne will be black. There is no way to calculate how the light should be bounced on the 3D object, so it just terminates on the object. If we connect this function to the material surface input, then we will see Suzanne based on the settings of the principled BSDF. And of course, besides the surface input, you also have a volume input, which is the input where the volume BSDF shader nodes need to go into, and the displacement input, which is where the displacement map needs to go into. So within this shader editor, if we press Shift A on our keyboard, then we can add different node types into the shader editor. And as you can see, the node types I showed you in the slides are all available in this menu. And within this menu, we are gonna select the noise texture, which can be found here. This noise texture you can also add by just typing in the search noise, and then you also get the noise texture. And this noise texture is used a lot when it comes to giving the material a little bit of randomness in the colors or in some other variables. So what we're gonna do right now is click the color output and drag, and then you drag out an edge out of the node. And this we're gonna connect to the base color. And as you can see, Suzanne gets a random color pattern, noise color pattern. And this is the color output, but you can also use the vector output. And as you can see, it gives it some random patches of black and white on the Suzanne. So then you have multiple settings on this noise texture as well. You can change the scale of the noise. For example, you want some large scale noise values, then you would use a lower scale number. And in this case, it's quite hard to see. So what we're gonna do now is introduce a add-on, which is called Node Wrangler. It's a very, very useful add-on. So to add this add-on, we go to Edit in the top, and then to Preferences, and then to Add-ons. I don't understand why they didn't put it into Blender natively yet, but maybe it will in the future, but everybody uses it. So, and then you think this Node Wrangler, I already have it enabled, and then it should be enabled. And when you added this Node Wrangler, then you can hold Ctrl and Shift and then click a node, and then it will show a preview of that node. Well, in this case, the scale of the noise texture is too large, and then you don't really see any detail. So what we're gonna do is crank the scale up. And as you can see, the larger the number, the smaller the detail is. And in this case, you get some nice patchy detail, which you can use for, I don't know, skin color or all kinds of things. And then you have a detail setting, which basically makes the noise texture more detailed. And it's better visible if you put it on a larger scale, like this. Now you see a lot of details in this cloudy area, but if you put the detail down, it just becomes like more of a smooth blob. So I usually use the detail, crank it usually up. And then you have the roughness, which goes hand in hand with the detail, as you can see. It roughens up the noise texture, and then you have distortion, which warps it around, which I usually don't use that much. And now we're gonna click Ctrl Shift and click the Principled node again to see what it actually does. Add this color. And what we're now gonna do is add a color ramp. So if you press Shift A and then go to Converter, there you have a node that's called color ramp. If you click on that, it will be attached to your mouse, and if you hover over an edge, you can see it lights up the edge. And when you drop this node on top of this edge, it will attach the input to the output of the previous node and the output to the base color of the principled node. It's just an easy and quick way to add some nodes as well. And as you can see, it will map the 0 to 1 values of this noise texture to this color map and output that in the color output. If we change this value, for example, as you can see, it now has a harsher cutoff of the color. So basically now it looks more like a cow or something. But of course, you don't have to do it black and white. You can also click one of these sliders, and then you have this color setting, and you can give it a color as well. For example, red, and we do the other one, we do blue, and then it will be a color map from red to blue. And in this way you can use this color map, you can use it as a color map within your visualization as well. It's a bit tedious because you don't know exactly which numbers are represented, only from 0 to 1. But to go further with the hands-on, I'm going to change the values again from black to white. From black to white. So this was a converter node, and we put in a texture node, and now we're going to put in a color node, and we're going to put in the color node hue and saturation, and we're going to do the same. We're going to place it on the edge, but with this automatic connecting, it connected the color to the color, but that's not what we want. What we want is to add it to a different input, for example the value input. So, but now we are missing a color, it's just white. So now what we're going to do is add a input node called RGB, which is literally just a color. And we're going to choose a nice and brown color and add this color to the color input of the hue and saturation value node. And as you can see, instead of being black and white, it's now black and brown, which can be changed with this noise texture. As you can see, the value of the brown color is changed based on the noise texture. You can do the same with saturation, for example. Then the high values, the 1 values of the noise texture, have a very high saturation, and the lower values have a low saturation. Same can be done with the hue, and then you get this super spacey looking Suzanne. It changes the hue based on the noise texture then. But we're going to put it back to value, and then we're going to change the color map so that it's just a brown color, but then with a little bit slight variation in the value, so it looks like a patchy skin, brown skin color. So next, what we want to add is some irregularities on the skin. So what we're going to do, what we're going to use for that is the bump node. And to add the bump node, we're going to press Shift A and then go to vector, which are the vector type nodes, and choose bump. And this is a vector node type called bump, which creates a normal map based on a height value. And what we can do is now use the same noise texture which we used for the color as the height value of the bump node. And then we're going to add this normal output to the normal input of the Principled BSDF. And as you can see, it becomes all wrinkly and now it looks like an old monkey. And it's a little bit too intense, because the strength and the distance are both very strong, and then you get a very strong bump mapping. So what we're going to do is change the distance value to 0.1, which is usually good enough to get some irregularities on the skin. As you can see, it looks a little bit more, a little bit less perfect, which everything real is not super perfect. And in this case, the surface of the skin is also not super perfect. But as you can see, this is a shader level operation only. This bumpiness you don't see on the edge, it's only on the surface itself. So the geometry is still the same. If you want to change the geometry as well, you should use the displacement node. So what we're going to do now is add a displacement node, and that can be found underneath the vector nodes. And as you can see, this is a displacement node. It has a displacement output which needs to be connected to the material output. Now it doesn't show anything because we didn't connect anything to the displacement node yet. But the same as the bump node, we can add something to the height node to indicate how far a vertex in a certain position needs to be displaced. But to effectively see what the displacement node does, we're going to remove the normal input from the BSDF shader, and then we're going to connect the same vector value to the height. And as you can see, it has the same horrible look as the bump map had, because by default the displacement mode also just does a bump mapping. But that's not what we want. We want to displace the vertices. So in order to have this displacement mode actually displace the vertices of Suzanne, we need to change the settings of this displacement node. If you select the displacement node, you can then go to the side panel. If the side panel is not present, you can press the N button and then it will reveal the side panel. And then go to options and then go to settings. And then you see at the surface level, the displacement is on bump only, which is the same as we did with the normal map. If we set that to displacement only, you see that the geometry is displaced and it looks horrible because the values are way too high. It's the same as with the bump map. You need to decrease the scale. Well, with the bump map it was the distance, with this decrease the scale. 0.1, we need to check a little bit, 0.2, 0.2, then you already see. But now you see that the displacement actually happens on a geometry level, which is what we want. But of course, now the displacement is only working on the geometry that is defined by the 3D mesh, but we want actually even more detail. At least I want even more detail. So what we're going to do is select Suzanne and we're going to add some extra detail. For this, we need to activate an experimental set and we're going to add some adaptive subdivision. For this, we need to first go to the properties panel and then go to the render properties and then go to the feature set and then select experimental. And then all the experimental features are added to Blender. And then when we activated that, we can add at the modifiers, add modifier, and then subdivision surface. And then there is a new option when you activated this experimental feature set, and that is called adaptive subdivision. And for now, it has a dicing scale of 1. And the dicing scale depends on the subdivision settings within the render properties. Now it's 1 and 1, so for the render it will make a subdivision per 1 pixel and for the viewport per 8 pixels. And to change these values you have to go back to the render properties and then go to subdivision, and here you have the settings. And of course we also want some more detail in the viewport. So we can change this to first to 4. Don't set it to 1 immediately because it might crash your viewport. But for me it will work, but for some it won't. As you can see, there's a lot more detail going on right now. But the thing is, it doesn't change, even though you zoom in, and you might expect that it should change because the subdivision is done on pixel level. But in order to have this change be applied, you need to go in and out the edit mode. So when you're hovering your mouse over your 3D viewport and you press tab and tap again, it will reload and start subdividing again, and then Blender will crash. So as you saw, it crashed for me. So it used too much GPU memory, and that's also because I'm also screen recording right now, so that also takes some GPU memory. So let's try this again, shall we? So for me it's back on 8. So if I press go into render shading mode and then wait for a second and get this detail of 8 pixels, and then press double tap, it should show a little bit more detail. And then with a subdivision per 4 pixels, double tap, it adds even more geometry. And of course, this also depends on the scale of the noise texture. If you change that, then it will also change the surface imperfections as well. But I have to watch out because I'm also screen recording, and it will crash again. It crashed a couple of times before. So I will keep it at subdivision per 4 pixels. But if you want to try it out, you can also put this at 2. And also watch out, it's pixel based. So if your screen resolution is 4K, it will do a lot more subdivisions. But then it will definitely crash Blender. So yeah, now that is all about tweaking Suzanne and the detail on Suzanne. But to add some little bonus effect, I'm gonna add some Fresnel shading at the edges to have this microscopic look, which I also added to the bacillus. And for this, we're gonna use a mix shader. So I'm gonna place this Principled shader a bit to the side and this a bit to the side. And we're gonna add a different shader called a mix shader, which will mix 2 types of shaders into one shader based on a factor. So if we then add a, for example, emission shader to the other one, it will light up, but we only want to have it lit up at the edges. So when the light, the angle of incidence is very small. I had to think about that. So if we add the Fresnel node and put this at 1.1, so I already tweaked it before, so I know this number will work, and I put it into the factor, and as you can see, you get this microscopic look. And it's because I think the microscopes are lit from all directions very intensely. So this was a very basic introduction on the shader editor. I'm now going to show you texture mapping and UV-unwrapping. But for this, we're not going to use Suzanne, but we're going to use a cube. So what we're going to do in the 3D view, we're going to press Shift A, and we're going to add a cube. And we're going to press G and move it a little bit to the side so that it's next to Suzanne. And then we're going to press Tab so that we are in edit mode. And as you can see, all the vertices are already selected, but if they are not in your case, just press A to select them all and Alt A to deselect them. So we're going to select them all, and then we need to go to the UV editor, which is a different thing than the shader editor. So we're going to replace the shader editor for now with the UV editor. We're pressing this shader type icon, and then we'll go to UV editor. So as you can see, this cube is already UV unwrapped. This is done by default by Blender. The default objects already have a UV mapping. And what you see right here is a typical cube projection to UV unwrap a cube. But yeah, we want to experiment with some more UV unwrappings. So the first unwrapping method is just the basic unwrap, which is based on seams in the geometry. We don't have any seams in the geometry right now. For performance purposes, I'm going to go into solid mode so that's easier to view. But to mark seams, you need to select edges and then press U and then mark seam. So that's what we're going to do right now. We're going to mark the seam so that it would unfold into a T shape. So first off, we need to deselect everything and then go to the edge select mode. And then if you select, then you select the edges. Then we're going to select the edges so that it would unfold into a T shape. And this would be it, I think. Yes, that would be it. And if we now press U, and then you have this thing is called mark seam, you can see the edges become red, and those are the places where the UV unwrap will cut. And if we then press A and select everything, and then press U and then unwrap, you can see it unwraps it into a T. Basically, what you also can do is mark every single edge as a seam. Press then U, mark seams, and then it will make different islands. So if you press unwrap right now, and then it will unwrap it as islands, as you can see right here. So now on to the next unwrapping method. First select all the edges and then press U and then press clear seam. Then we removed all the seams, and then we press U and then we're gonna select the Smart UV project. And then within this we're gonna add a little bit of margin for the islands. And if you then press OK, you can see it, every single face is a different island with space in between. And of course with a cube it's rather obvious where the seams need to be to have a good UV unwrapping, but if the geometry is a little bit more complex, you can use this Smart UV project to make relatively nice UV unwrappings. And then last but not least is the project from view. We still have all our edges selected, so if we then press the U button again and then select project from view, as you can see, it literally projects what you have in your view. This, as I said before, can be useful if you see an object only from the side. And within this UV editor, you can also select these UV coordinates and do the same as you can do with the 3D geometry. You can press G to translate it around, you can press S to scale it, you can press R to rotate it. And that way you can manipulate the vertex positions. So now that we have a little bit of understanding how this UV unwrapping works, we're gonna make it a little bit easier to understand by adding a texture to this object. And you can actually see what this UV unwrapping does to the texture itself. So for this, we need to go back to the shader editor. So we're gonna click this icon, go back to shader editor and press new. And then we get a new material. This is just the basic material. And then we need to add a image node, a texture node, and then a image texture node. And then we need to connect this color to the base color of the Principled BSDF. And then we're gonna open up from the advanced materials walkthrough directory in the data, and then textures, and then UV test point PNG. And if we then put it back to shaded mode, it is projected like we did in the UV unwrapping, and we chose project from view, and as you can see the texture is directly projected from view. And in this case it will use the UV coordinates as a vector input on this image texture, but that is not always the case. And in that case, we need to add a new node called texture coordinates. And if you press this text, if you place this text coordinates, you can see there are different types of coordinates. You have a generic generated by Blender coordinates, normal coordinates, UV coordinates, but we are just going to use the UV coordinates. It looks exactly the same, but for example, if you choose generated, which are just basic texture coordinates created by Blender, which are not very useful in this case. So back to the unwrapping. We have to go back to the UV editor because now we added the texture in there. And if you go back to the UV editor, as you can see at E4 is here just like it is on this. But if you then grab one of them and change it around, you can see, for example, E5, now E5 is there, and F4, now F4 is there. And that way you can also manually manipulate these UV coordinates so that it maps the texture the way you want to. And then finally, of course, if we unwrap it with the cube projection, it will have the texture on all sides. And with this, I showed you the basics for the UV unwrapping and texture mapping. So I hope this UV unwrapping was clear, because now we're going to shade this cube with PBR-style textures. PBR stands for physically based rendering, and basically it's the same textures I showed you in the slide with the wooden plank. And so we need to add an extra set of textures to the shader editor to make this cube look like a metal ball. So for this, we need to go back. We can go out of the edit mode. So I'm going to press tab. Then we're out of edit mode. And then we're going to go back to the shader editor. And then we're going to select the image texture. And then duplicate it 4 more times. Because we're going to add 4 more textures. That's a lot of textures. And then the first one we're going to connect to the color to the metallic input, which is going to be the metal map, which says which part are more metal and which are not. And the second one we're going to put on the roughness map, which is going to determine which parts are rough and which are not. And the next one we're going to connect to a normal map node. For this we need to go to vector type nodes and then normal map, and then attach the color to the normal map, and then the normal to the normal input, of course. And the last one, we need to add a displacement map. So Shift A, search displacement. This is the easiest way to find node, just type it in, and then attach that to the height of the displacement, and then add the displacement mode to displacement. And now, of course, the texture mapping needs to be done the same as this one, so with the UV, but I don't want to copy it all again. So what I'm going to do is select this node and press Ctrl-T, and as you see, it already automatically adds UV texture mapping with a mapping node in between, so I can also change the position of the textures within this shader editor itself. And this is a feature added by the Node Wrangler add-on. So this is the same as the Node Wrangler before. You can use this for your own convenience. So I'm going to do that for all of them. I could also connect those all to the same one, but if you want to change them independently, you can do it like this. And of course, then we need to also open the right images. So for the first one, I'm going to go to the data directory of the walkthrough of the advanced materials, and then go to textures and then metal textures. And there you have different types of textures. The first one we need to add in the first node, the color texture. And if we do that, well, it still looks weird because we still have the UV test on every single input, so that's going to change. For the second one is metallic, so we need to open up in the same directory the metalness texture, so metalness 3K metalness. And then because this is not really a RGB data texture, we need to select non-color data so that it will be treated as a non-RGB value. And then the next one, which was the roughness, we're gonna open up the roughness map, which is called roughness 3K metalness. And the same goes for this one. It's not an RGB value, so it's non-color data. And this one is the normal map. So we open up metalness texture, normal, and then also select non-color data. And then finally, for this last one, we're gonna open the displacement map, which is also non-color data. And as you can see, it already starts to look like a metal cube with some metal textures on it. But for me, the normal mapping is a bit too rough. So what I do is change the strength to 0.1. As you can see, it still looks a little bit off. It still looks off because this displacement map is also way too strong. 0.1, and of course you knew before that the displacement also needs an extra setting. So if you select the displacement, go to the side panel, options, setting, and then displacement only. And of course now we don't see the displacement yet because we only have 8 vertices and only 8 vertices to displace. So if we then go to the modifiers, add a subdivision modifier, and because we already used it before, we can just click subdivision modifier, and as you can see, changes it into a perfect metal ball with some indentations. And that's a PBR workflow, and you can use that with any of the textures on Texture Haven or Polygon, and then you can get these realistic looking materials. And that's everything about the shader editor. Of course, there is a huge set of nodes still available, but I cannot touch them all. I just showed you the basic workflows within this shader editor. But if you want to see any more great examples, just go to Twitter and search for November, #November, and then you get the craziest shader editors. And usually they also add blend files or show you the node network itself, and then you can learn a lot from those as well. It's a lot of skills I learned from these type of examples. So now I do believe you're ready for the assignments, and I wish you good luck with them. If there are any questions, please let us know on Discord. Good luck.